All right, welcome to class once again. Tonight we'll be talking about learning curve theory. Learning curve theory. The questions on learning curve sometimes might not come as a full-fledged question. It can be an addition to a particular question, to a particular topic. It can be tested alongside with variance when talking about labor variance. It can be tested alongside with, let's say, relevant costing and as well. So sometimes you won't just see it as as a full-fledged question on its own, but can just be an addendum, an addition to some other question. Yeah. So when we talk about learning curve, please you can write because sometimes when I'm teaching, I might not always talk in relation to my slides, but certain things I'll be saying might not be in my slides, so you might need to put them down because they might also be helpful to aid our understanding. So when we talk about when we talk about learning curve, everybody we is a practical thing that happens to us. Yes, it's a practical thing that when you start a task, when you were newly employed to handle a particular schedule in your organization, the first time you perform that task, you were a little bit slow. And sometimes you might even be frightened because you don't want to make mistake. But as you keep doing that task, you improve, you get better. Now, the effect of you getting better is as a result of the fact that you are learning and you are repeating that task over and over again. So, learning curve is a concept that shows how workers or organizations become more efficient as they gain experience in performing a task or in producing goods or service. So that is learning curve. In other words, I will say that learning curve is the more you do something, the faster and cheaper you become at doing that thing. The first time I was to teach PM, that time we're using, let's say, WhatsApp, doing voice notes. Yes, maybe about 4 years or 5 years ago, when I indicated interest, I want to teach in APES in PM. Yes, in my first class, I might, if I have the record, I might not have performed as expected, unlike as I am today. Yes, that I can decide to come up to teach because I've been doing it over and over again, and some of these things have been part and parcel of me. So that is the effect of learning and the function that I am doing it over and over again. Yes. So I said the learning curve is a concept that shows how individuals, organization, workers, team becomes more efficient as they repeat a particular task over and over again. So there is the effect of cumulative production. So as cumulative production increases, the average time or cost per unit decrease due to learning and gaining what? Efficiency. If you use 1 hour the first time you are doing a task, the next time you'll be doing it, you should use less number of hours. You should use less time. If I should use 1 hour in trying to fix a boat, The next time I will do that task, I should use, let's say, 50 minutes. The next time I will repeat that task, I should use, let's say, 40 minutes. There should be a decline in the number of time I use to perform a particular task, But it will get to a point whereby no matter what I do, I won't be able to reduce the time because I've become an expert in that particular task. So every concept I need to apply, I've applied them. So at that point, learning curve will be zero because you won't be able to improve further than where you are. And at that point, we can say you're an expert. You're an expert. So you keep performing at that particular level, at that particular using same hours over and over again because you gain mastery of what you are doing, of what you are doing. Now, the key concept about learning curve is that experience improves performance. Experience improves performance. So each time cumulative output doubles, please take note of the word doubled. If you look at the slide, though I'm not speaking to the slide now, I put that doubled in and in red in red color because when you see question, you must note that learning curve operates based on doubling effect. Doubling effect. It means it will always be from 1 to 2, 2 to 4, 4 to 8, 8 to 16, 16 to 32, in that order. But where you have as part of your output, you have 3. It shows learning effect cannot affect that 3 because there is no doubling. Please take note of that. Yes, because you see some questions, you can be asked to determine the number of hours required to produce the 13th batch. You cannot actually get that perfectly except you get what? You get, let's say, okay, let me change the example. You can be required to get the number of hours required to produce the 13th, the 15th batch. Now, you won't be able to get that perfectly except you know the hours you need to produce your 16th batch. So when you know the hours you need to produce your 16th batch and you know the hours you need to produce one batch, the difference between 16 batch and one batch will give you your 15 batch. You must get that idea. That concept must be with us. That the concept of learning curve work with doubling, doubling, 1, 2, 2, 4, 4, 8. Yeah. So where a question is trying to test you now, that determine the cumulative average time for the 5th batch or for the 7th batch, you must know the 8th batch, the hours required for the 8th batch, and the hours required for the first batch. The difference between 8th batch and 8 batch hour and 1 batch hour will give you the time for the 7th batch. Take note, it can come in a word problem form. Yes, so that when you see such scenario, you won't be trying to use maybe a tabular approach to solve that. It's much more easier to use a formula approach. We'll get to that point. So as I was saying, that experience improves performance, that each time cumulative output doubles, the time or costs required to produce each unit falls by a fixed percentage. The rate in which the time falls can be termed as what? Learning rate. Learning rate. Learning rate. Now, what do we mean by learning rate? For example, if you perform a task and the percentage in terms of hours falls by 20%, you can say the learning rate is what? 80%. So if the learning rate is 80%, it means that every time production doubles, it takes 80% of the previous time to make the next unit. To make the next unit. Before I speak to my slide, let me give an example of what I'm trying to talk about. That for example, let me say, for example, let's say we have our first unit. First unit, you use, let's say, 10 hours. You use 10 hours to produce your first unit. What will be the doubling effect of your first unit? To be 2. 2 times 1 is what? 2. So the second unit now, the second unit will be what? We are assuming a learning rate of what? Of 80%. Learning rate of 80%. The learning rate is 80%. How many hours will you use to produce the second unit? The second unit or batch now. How many hours will you use? It will be what? It will be 80% of what? 80% of what? Of 10.
10 hours.
Of 10 hours.
Of 10.
80% of 10 hours. And that will give us what?
8
8.
hours.
8 hours.
8 hours. To give us 8 hours. Now, when you double the second unit, you're going to have what?
4.
Fourth unit.
4.
You're going to have the fourth unit. So now, what will now be the effect of your learning rate on the fourth unit? It will be 80% of what?
8
Of the
8 hours.
80% of 8 hours. 80% of 8 hours. And that will result into what?
6.4 hours.
6.4 hours. So the more you double, the less time you use. The less time you use. So we must know that in learning curve, as activity is being doubled, the cumulative hours is expected to reduce. So the cumulative effect, the learning curve effect is strongest at the beginning when you are just starting a task, when you are just learning. Yes. Then it slows down as the workers becomes highly skilled. So as you become an expert in a particular task, there will be no effect of learning curve again. Learning curve will be meaningless at that point, because anyhow you do it, you still use, let's say, 1 hour. No matter how you try, you still use 1 hour. For those that are driving, no matter how you press your acceleration, you press it. If you to take you 2 hours to get to don't let me use, I'm not used to Lagos. I know some of you are in Lagos. So I think I have somebody in Jos here. I have some people in Jos here. I think Nangil is in Jos. I don't know if this other woman is here too. So for example, let me use my environment now. If it would take me where I am, let's say 30 minutes to get to University of Jos from this my location, based on the fact that I'm just learning how to drive for the first time, by the time I continue driving, observing the various traffic routes without any hold up, without any traffic, because I've become a master in that, and I keep using, let's say, 10 minutes to get to University of Jos, from this my location, it means no matter how I try, I'll definitely use 10 minutes. I cannot use less than 10 minutes. I cannot use above 10 minutes. So at that point, I've become a master, an expert in driving. So learning curve will have no effect at that point in time. So learning curve makes more sense, can be measured when you are just starting a particular task, a particular task. So the learning curve effect is strongest at the beginning. So and it slows down as workers becomes highly skilled. So that is this learning curve. That is learning curve for us. So it is very useful because it helps us to predict future cost. Yes, in terms of labor rates, it can help us to predict future costs, and it can also help in setting prices more competitively, and it helps in budgeting and so on and so forth. And it also helps organizations to determine if their workers require training when you are performing below expectation, and it can help organizations to know if there is need to train their staff to operate in accordance to required standard. So that is why learning curve is coming in. Sometimes students always ask questions, what is the meaning of this to our day-to-day life? Some of these things are practical. It's just that our country is not an industrialized one, whereby most of us are expected to be working in such places. Then we begin to see the effect of this in our day-to-day activity. In industrialized nation, they use these principles, this approach to evaluate their performance. So that is why it is very important we know them. Yes. So let's speak to our slide now. From this slide, we said that this theory postulates that whenever a repetitive task is being performed, the average time spent in producing a unit falls by a percentage. So whenever the activity level is doubled, take note, is doubled. So if the average time falls by 20%, then a learning phenomenon of 80% is present. If the average time keep falling, as I produce 1 second, it keeps falling by 20%, 20%. It means the learning rate is what? 80%. But if the average time falls by 30%, then the effect of learning will be what? 70%. So the underlying logic behind this theory is premised on the fact that human being, unlike machine, acquires a lot of skills, experience, exposure, specialization, and dexterity for performing a repetitive assignment. So this theory will not work where you use machine, where you use mechanized way in performing your task. So it works where you have manual labor. You use humans to perform a task. So that is when this theory will hold water. So the conditions, that is the theory of learning curves, will only hold if the following conditions apply. That is, there is a significant manual element in the task being considered. The task must be repetitive, and production must be at an early stage so that there is room for improvement. And more so, there must be consistency in the workforce. It means not that you work today, tomorrow you are not there. So when you are consistent in doing a particular task, you'll be able to measure the learning effect on you in relation to you handling that particular task. So there must not be extensive breaks in production, or workers will forget the skill. So it's still in relation to being consistent. So there must not be too much production downtime. Production must always continue. There shouldn't be cessation in production process, so that these learning effects can be measured as appropriate. And also workers must be motivated. There must be motivation for workers to give in their best in performing a particular task. Performing a particular task. So a learning curve is can be represented as seen above, that when you start a particular task, the first time you start at this point of origin now, let's say we have one here. The first time you commence a task, you can see the average time will be very high. The time will be very high here. But as you keep producing, the average time falls, it declines, as you keep producing. So you now get to a point whereby no matter what you do, it will just be a straight line. Yes. So at the first instance, when you start production, you start learning, you use more time. Average time for all unit produced to date, you use much time. As you keep producing, it falls. As you keep producing, it falls. As you keep producing, it falls. Now get to a point, the curve will just become straight, because no matter what you do to improve your performance, you're already a master. There's nothing you can do at that point. So that is learning curve for you. This is how it looks like. This is how it's been represented. So in case you have to plot it in a graph, yes, I'm showing this, you understand the concept. So the learning curve effect can be calculated by using two approach. We have the formula approach, otherwise known as the algebraic approach, and we have the tabular approach. So the method one, set up a table and reduce the average time by the learning rate each time the output doubles. Each time the output doubles. Let's see, I think I have an example here. Yes, this is an example to corroborate that method one, that you can have number of units. You can have cumulative units. Cumulative is present plus previous. At when the output is 1, the cumulative will be what? 1. 1 plus 0, 1, because there's nothing before 1. So at this point, when you double 1, you're going to have what? 2. That is 1 plus 1, you're going to have 2. When you double 2, the cumulative will be what? 4. When you double 4, the cumulative will be what? 8. When you double 8, the cumulative will be what? 16. So when you work in this light and you are given a particular time in a question, for example, I think in this question we're giving 1,000. So, and the learning rate is what? 80%. 80%. So the time will keep on reducing by 80%, just as I've shown in a very simple example before now. The time will keep falling in that light. So we can use two approach. The tabular approach, and we can use the formula approach. But take note, the tabular approach will not always work in all circumstances where you don't have the doubling effect. It will not work, because by the time you see a question, you're trying to apply that concept, it will not work. So when the output is not being doubled, for example, I said you can be asked to determine the 15th, the time taken to produce the 15th batch. 15 is an odd number. It's not an even number. It does not have the concept of doubling in it. In that case, this formula approach can serve better. So, but the point is, in most instances, when you use the table and the formula approach, you arrive at the same answer. That is where you have the doubling effect. So in certain instances, this table approach will not work. So you need to use the formula approach. So using the formula approach, you have y equal to ax to the power of b. What is y? Y is the cumulative average time or average cost. Sometimes, the learning rate will reduce the cost of labor, the labor rate, reduce labor rate. That is why you can see cost in brackets, because you can have a question whereby they'll ask you to determine the reduction in the value of cost based on the learning effect. So that is why you can see average cost in bracket. So Y is cumulative average time per unit or per batch, and A is what? Is the time or cost for first unit of batch. The time or cost for first unit of batch. And B is what? log r divided by log 2. Log 2 is always constant. Log r is the rate of learning and is expressed as a decimal. If the rate of learning is 20%, that is 0.2. The rate of learning is 50%, that is 0.5. So you determine your rate of learning from the question when it is given. You divide, you type on your calculator log 0.2 divided by log 2. Then you determine the value of B. And X is what? Cumulative output in units or in batches. So both method will give same answer. However, the formula is quicker and easier to use in the exams. Yes. Any question at this point?
Yes, sir.
All right, so what is the question, sir?
Okay. I would appreciate if you can use that formula to apply in the example. That's the tabular example of 1,000 hours. And let's see how. Let me see how you will do that, sir.
Very well. I'll definitely use I'll solve a question using the tabular approach and using the formula approach to see how we can arrive at same answer. Yes. So
Okay.
we yes, definitely the class will not be complete if I didn't do that. Yes. So we are going to look at this example. This example, the example reads us that assume that it has taken 400 direct labor hours to manufacture the first unit of a new product. The first unit of a new product. It it takes 400 direct labor hours. So as in the past for this business, it is anticipated that a 75% learning curve will occur. Required, set up a table showing the average time taken for the second and the fourth unit, and also the total time taken for 2 units and for 4 units. The total time taken for 2 units and for 4 units. The first is the average time taken for the second and the fourth unit. For the second and the fourth unit. Now, we've been given the time for the first unit to be what? 400 direct labor hours. Now, if we double the first unit, we're going to have what? 2. 2. And the learning rate in relation to 2 is what? Will now be what? Or the learning rate given in the question is what? 75%. So for us to get the average time for second unit, what are we going to do? For us to get the average time for the fourth unit, what are we going to do? So we're going to you can screenshot the question in case. We're going to present it in this form. We have solution. We have solution.
So the question, please.
So we have the question, then solution. So we have it at okay, set up a table showing this. So we'll have a table. Can decide to just give a label in this form for understanding purpose. That's the cumulative number of units. You need to determine your cumulative number of units. Cumulative units. Cumulative units. The first unit will be 1. When you double 1, the result will be what?
2.
When you double 2, the result will be what?
4.
4.
4. Based on the question that we should determine the average time taken for the second and the fourth unit. Now we'll stop here. That's why we are stopping here. If it requires us to go further, you will double 4. If it requires you to go further, you will double 8. So take notes. So we are working based on the direction of the question. So cumulative units, we have it as this. Now, the cumulative average time per unit. The cumulative average time per unit will be what? The cumulative average time per unit. Let's have it as average time. Average time per unit. For the first unit, we're giving what? Assume that it has taken what? 400 direct labor hours to manufacture the first unit. So how many hours do you have for the first unit?
400.
Now, if you have 400 hours for the first unit, how many hours will you take to produce the second unit? What will be the average time for the second unit if the learning rate is 75%? If the learning rate is 75%.
300.
300.
If it's 75% of 400.
Or 400.
75%.
75% of 400.
We'll have it as what? As 300. This will be the average time per unit. The average time per unit for to produce the second unit. Now, what will be the average time taken for the fourth unit? For the fourth unit, it will be what? It will be 75%.
300.
25%
Of 300.
of 300. Then we have it as what?
5.
225. 225. That is the average time for second and fourth unit. Now the question is now asking us again, what is the total time taken for 2 units and for the fourth unit? For you to know the total time or the total hours, what are you going to do? The total hours. What are we going to do now? It will be your cumulative unit multiplied by what? The average time per unit. Cumulative unit multiplied by the average time per unit. That is representing this. C is A multiplied by what? By B. So for the first unit, even though the question is not asking us to determine that, but you need to determine that to have a complete table. So it will be what? It will 1 multiplied by what? By 400. You have it as 400. For the total hours, sorry, that is total hours. What's I'm saying now? Total time taken, yes. So total time. So we have the total hours for the first unit will be 400 hours. For the second unit, it will be what? it will be 2 by 3. So we have it as what? 600. The total time for the fourth unit will be what? To be 4 multiplied by what? 225. We have it as what?
450.
900.
Ah,
We
sorry.
have it.
900.
What makes you
We
miss?
have, we have it as what? 900.
900.
We have it as 900. So the average time for the fourth unit, for the second unit is 300. For the fourth unit is 225. Now, let's move further now. Let's move further. That using the information from the previous question, test your understanding by using the formula to calculate the cumulative average time to produce 4 units. That is the fourth unit now. Now, you know, we show this formula. Y is equal to what? Ax to the power of b. So we said Y is what? Cumulative average time. Cumulative average time or average cost per unit or per batch. And A is what? A is what? Time for the first unit of batch. B is what? Log R divided by log 2. That is, R is what? Your rate of learning expressed as a decimal. And your X is what? Cumulative output in units or in batches. Cumulative output in units or in batches. Now, based on this formula, write this formula out, please. So we're now going to go back to our question up there. Yes, because we want to know, to see if we will determine what? If we can arrive at 225 using that formula. Because the question is asking us that use the formula to calculate the cumulative average time to produce what? 4 units. So let's now see if using the formula we can arrive at this 225. So solution. The formula is always behind the question paper, but it will not cost you anything if you just know it. It will give you more confidence. Yes, rather than waiting for the one behind the question paper, but it's always there anyway. So, but as you keep solving, it will become part of you. Like you don't need to be dependent on that. So, solution. So based on that formula, the formula is what again? That is Y equal to what? Bring it here. So now we need to determine our Y, because the question is asking us to determine what? Cumulative average time to produce the fourth batch, the four units. Now, based on our solution, the cumulative average, the average time is what? So it's 225. 225. 225. So now we want to determine Y, because from the definition of the formula, Y is what? Cumulative average time. So based on the question, what is A? A is what? Go and check the interpretation of the formula. A is equal to what?
A is the time of
Cumulative
cost
average
for
time.
first unit or batch.
200.
Oh, fine. Thank you, sir. So what is the time now?
400.
400 hours. 400 hours. Now, what is X? What is X
Cumulative output in units.
or in batches? So based on what we are considering, we are looking at the fourth unit, right? We're looking at the fourth unit. So what is the cumulative output at that point? Is 4. Is 4. Cumulative. This is it. 1 plus 1. 1 plus 0, 1. 1 plus 1 is 2. So the doubling effect now, that is, we can say it in this way, that is 2 times 1 is 2, 2 times 2 is 4. But if I should add another column, I can say 1 plus 1 is 2, 2 plus 2 is 4. So that will give us this cumulative here, which is 4. So based on what we're treating, we want to determine the cumulative in terms of the cumulative hours, and the cumulative in relation to the fourth unit is 4. We're looking at the fourth unit, and that is the cumulative. The cumulative, that is the last value there, the last value. So based on that, what would be your B? What is B? B is what?
Log R divided by log
Did
2.
you
So what is log R?
Rate
log
of learning.
0.75?
Okay.
Yes. So we'll now have it this way. B is equal to log what? Log 0.75 divide by what? Log 2. Divide by log 2. If you have your calculator, you can determine what log 0.75 will be. If you don't have a calculator at this point, I don't think you are doing yourself good. So log 0.75 will give us what?
Minus 0.124.
Minus 0.124. Is it just
No,
0.124?
no, 0.124, 98, 73, 50.
All right. Somebody is in church here. So if you know you don't know how to press log on your calculator, speak out now. Maybe your calculator is a special one that you're not seeing log. All right, you should have, once you punch it, you should have 0.1249. Log 2 is what?
0.3010.
So when you divide, you're going to have what?
Zero
Minus
point
0.4150.
4149.
So can you substitute all these values into this equation to get y? Y will now be equal to what? What is A? 400. Multiplied by what?
400.
X is what? X is 4. B is what? Minus. You know it's to the power. Minus 0.4150. Let me raise it up. You know it's to the power. Don't just go and press Something special. Yes, it's to the power. So can you simplify now? Let's see. The result is what?
225.
225. Who is not getting 225? Somebody's in this class is just imagining what is this again. So it's nothing big. So have we all gotten 225?
Yes, sir.
Okay, all right. If you didn't get it, don't worry, just speak out. I have your time. Okay, that is good. So now, since nobody is talking, help me solve this question. I need answer now. Where is this question now? This is a question. Help me solve it. Let me help you read.
Sir,
Let me help
I
you read.
already solved it. I got 45 now.
Okay, you've solved this one already.
Yes.
Okay, fine. What did you have? What is your answer?
45.
45?
45 hours. Yes. That's what I got.
This question,
Yes.
45. Okay, let me even
I
read.
used the formula method.
The time taken to produce the first unit is 100 hours. Okay, there is a learning rate of 75. How long will it take to produce an additional 7 units? How long will it take to produce an additional 7 units? Yes. You know, I mentioned something the other time. This 7 units is not a doubling unit, isn't it? It's not 8. So something is happening here. For you to know the number of hours you need to produce 7 units, you must know the number of hours for what?
8 units.
16
8
for the
You
eighth
must know
units.
unit.
the number of hours for 8 units. Then the difference between 8 units and 1 unit will give you what? 7 units. Will give you 7 units. Will give you 7 units. Will give you 7 units.
Okay.
So can you try? Can somebody just try and do something? Just do a table. Come up with a table. Yes. Come up. From there, we'll now move. Come up with a table. The time taken to produce the first unit is 100 hours. It means you have 1. When you double 1, you have what? Then you now, since they are talking about 7 units, you have to stop at what point now? At 8.
8.
At 8. Then you now determine your average time. For the first unit, it will be 100 hours. Since you have 75% learning rate, what will be the average time for this second unit? It will be what? So come up with a table. Come up with a table by yourself, even though it's rough. Do something. Do something. You know, sometimes when we leave the class, some of you don't have time again. And some students, they like class, but they don't have time to go back to their book. So when teachers
Can I
don't come,
use formula for this?
you can use formula, but you start with the table first.
Okay. Did I know that the table formula?
Maybe I should go back to the table again.
Yes, sir.
It's something like this. It's something like this. So what you're expected to do is just something like this, likewise. So let me now go back to the question.
Eight units, I got 42.
Okay, fine. Yes.
The answer will be 58. Oh, 42. Yeah, 58. I think so.
Okay, what is the question saying? How long will it take to produce an additional 7 units? Okay. How long will it take to produce an additional 7 units? So once you get your average time, you get your total time. Take note, sir. When you get your average time, you get your total time. You know, they are saying how long will it take to produce an additional 7 units? So the total time for 8 units minus the total time for 1 unit will give you the time you need to produce 7 units. See the table. Once you get your
That is
average,
the question. Okay.
once you get your average, you get your total. You understand? You know, in learning curve, please let's take note of these words. Your average time is different from your total time. Average is different from total. Yes. The first one we solved, what we try to determine the average. That is y. The definition of y is what? Cumulative average time. Cumulative average time. But now we want to determine the total. How long will it take to produce an additional 7 units? Not the average time now. So what will be the total time for the 8 units? For the person that determined 42, it's just 8 multiplied by 42, right?
337 or 338.
2.19
336.
Yes. So the difference between that 8
and 1.
and
minus
1 will give you what?
Okay.
I
That
got
means that one will be
237.6.
okay. Let me
Yes. 2. Yes. So you have something like that.
okay. As regards that 7, sir,
Yes, ma'am.
are we going to slot the figure meant for 7 in between 4 and 8? Or it
No,
will be
no.
separate? Okay.
No, you just do a workings to show that.
Okay,
Yes.
on a separate page.
Yes. It's just a workings that will show you that will show the examiner or the marker
Okay.
that
Okay,
this
for the
is.
7.
Yes.
All right, sir.
It's a kind of word problem point. So I have an example. I don't know if I'll be able to talk about that. Once you see such things, 7, you just cycle it. It will not have
Okay,
effect
sir,
on
so
you. Right?
you said the total time will be what now? Let me, because I am getting total time. Is it 674 hours or what? At 8.
At 8, it will be at 8, it should be 42. At 8, it should be
I
So
got
42 times 8. Okay, sorry.
yes,
42.19. 42.19.
42.
yes.
Okay, 42.18 times 8. Okay, I did times 16. Okay, sorry.
Uh,
Sir, sir, to get that 7, will it be the 100 minus the 42 for 8?
yes. Once you multiply 8 by 42, the total time for 1 unit is what? 1 times 100 is what?
100.
Fine.
100.
So 337.5 minus 100 will
Yeah,
give you what?
Okay, is that one? I use the cumulative time per unit. Okay. Times.
So this is it.
100. That's 237.5.
Okay. Okay. This takes constant practice.
Yes, it's constant practice.
You can easily get lost.
All right, let's look at one more question.
So that means if you want to do the subtraction, okay.
Yes, ma'am.
So is the figure under the total that we will use.
Yes, ma'am.
Me, I use the figure under average time.
I know you should don't worry. It's part of the learning process. When you solve it again, you use
Learning
1 minute. You use 1 minute to
learning
solve.
curve
Yes.
at the
No,
beginning.
that is one thing with this with solving icon questions. Sometimes you can pick a question for the first time. You can use 45 minutes to try to unravel what is there. Yes, but by the time you are able to untie the knots, by the time you keep solving, you use less time. And that is why it's very good to practice and practice. Yes. So if I'm the one now, I can solve this question like 5 times. I won't just solve it once and say, I've known it. No, that is not how me I learn. So I can decide to solve a question like 2 times, 3 times, just for me to understand certain things. Because when I solve first, I will make certain mistake. So I want to guide against that mistake again. So I will solve again. Yes. So that is how to do some of these things. And when you see such things in the exam, you use less time and you have much time to be able to tackle much questions. So let's see what this question is saying. Can somebody read?
The average variable cost of producing the first batch of 2,000 liters of flavored milk by a certain dairy company is 20 naira per liter. From the past experience, the company's operating costs decreased by 25% each time the output is doubled. Required. Use the data given above to demonstrate your understanding of the theory by finding the learning ratio and the average cost of producing 32,000 liters of the products. I can adapt it.
Yes. Yes. So can you meditate on this question? Everybody, let's look at the question again. Read it on your own again. Look at it critically. What can you bring forth? What can you deduce from this question? Yes, let's look at it. What can you, yes, come up with facts? That is how to attack the question in the hall that day. Yes, you take charge of the question. You bring out your variables, write them out. Okay, I can see first batch, 22,000 liters. Good, fine. First batch, 2,000 liters of flavored milk by a certain dairy company. The cost, now they are moving us to costs now. Cost per liter is 20 naira. Okay, 20 naira. From the past experience, the company's operating cost decreased by 25%. This is just like a learning rate now. 25%. Each time the output is doubled. Required. Use the data given above to demonstrate your understanding of the theory by finding the learning ratio and the average cost of producing what? 32,000 liters. So what will happen here now? If the first batch produces 2,000, how are we going to get 32,000 liters? Yes. Somebody should tell us, please.
By doubling the liters.
Yeah, so yeah, sir. Double it, double it. Let's get to 32.
So we use formula.
Okay, so the first cumulative this thing, the first time is 2,000 liters. Then
Yes, sir.
the it took them 100 hours, assuming. Then the second batch should be 75 times 100, which will make it 4,000 liters. The figure you
Okay.
get, you will use 4,000 times 4, which will make it 16,000 liters. And that is the 8. Okay, the doubled 8, right? 4 to 8, yeah. Then the figure you got at that 75 times 100, you will times it by 75 now. I think something like that. You should be getting
Okay, yes.
75. Yeah. Then the 8th time you should be getting 56.25. Yeah. Then the 32 liters time you should be getting 42.18 as the average. It's similar to the question we just solved.
Okay. All right now. So the point is this. Yes, the doubling effect is fine. 2,000 liters being the first batch. When you double 2,000, you have what? 4,000. When you double 4,000, you have what? 8,000. When you double 8,000, you have what? 16,000. When you double 16,000, you have what? 32,000. Isn't it?
It is.
Okay, fine. So from the past experience, the company operating costs decreased by 25% each time the output is doubled. So what would be the learning rate now? What is the learning rate? If outputs decrease, if operating costs decrease by 25%, at what rate are you learning?
75.
25.
75.
Very good. You are learning at the rate of 75%, because every time you engage yourself in operating costs, you reduce the operating cost by 25. It means you are performing at the rate of 75%. Now, what is the operating cost for the first unit? The operating cost is what? The average variable
20
cost
naira.
of 20 naira.
15 naira.
The operating cost is, the variable cost is what? 20 naira. It's
20 naira.
20 naira per liter. So the point is this: if you are reducing costs at the rate of 75% and you incur 20 naira at the first instance when you produce 2,000 liters, when you are producing 4,000 liters, what will be the cost? At what rate will you reduce it? It will reduce to what?
15 naira.
15 naira.
15 naira. Fine. So when you increase your production capacity to 8,000, the cost will reduce at what rate again?
$6,000.
6,000.
You have 11.25. When you double 8,000 again,
8.44.
yes,
8.44.
8.44. So this is it.
You solve it and hide it.
So this is it. So look at it very well, so that when I ask a question, you'll be able to help me out. So any question in relation to this? Any question in relation to this? So you help me solve this as an assignment. I have some other complex questions, but I don't want to bring them forth tonight.
Sorry, sir.
Like
Mr.
I have,
Cooper.
yes, ma'am.
Hello, sir.
I'm with you, ma'am.
I want to ask you.
Yes, I can hear you again, ma'am. Hello, ma'am. I can hear you again. Okay, please. This is the assignment. You can quickly put it down and solve. So this is a question. Madam Tolani, can you speak now? So aside her, anybody's having question? Is anybody having question? Can you hear me, please? Can anybody?
Yes, sir. My question is this.
All right.
This learning curve, this
Yes.
concept, is it still futuristic because of the advancement of automation?
Yes, that is the demerits now. Automation will not make this to be much more variable, because when machines are taking place of human activity, even though we always try to console ourselves by saying the machine cannot work on its own. It needs human efforts to work. Yes, that is what we always tell ourselves. That can ATM just work on its own? We know, but it's reducing the number of humans that should be in a workplace. So the point is this: with automation, you cannot evaluate learning curve. It is when the activity is done manually, that is when learning curve will be much more appreciated. So with development, learning curve does not have its place. So that is why the conditions where learning curve operates, the activity must be done manually. So that is it. So with where activities are carried out with machines and other things, the machine can keep working and working, yes, without getting tired. So it does not learning curve will not be measurable, will not be relevant at that point. So that is some of the demerits. Yes, because automation reduces manual learning, because the concept of traditional learning curve is based on human workers gaining skill over time. So with automation, machines handle the repetitive tasks. So human learning effects will be very much more smaller, insignificant for those tasks. For example, now when you have a robot, when a robot wheels consistently on day one, it does not learn like a person. Yes, you understand? A robot does not learn. It has been configured to keep performing that task. But when it is human, when we conclude this class now and you go back to your notes, the first time you are reading it, the understanding might not be that there. When you go back to it again, you learn something, you advance, you develop. understanding increase. So the point is with automation, human effort cannot be that, is not that measurable. Is not measurable. So with automation, new forms of learning is coming up. New form of learning is coming up. The use of softwares, AI training, and the rest of it. So, and it's bringing up new set of skills. So that is that with that. So I have an assignment which is right on the screen that Flogel
Sorry, sir.
limit. All right.
Sir, please, that example that you said the sugar result, I want it, please.
You want the
Yes,
question?
the question of that example.
Don't worry, I will filter my slide and forward to the group.
Okay, sir.
So the assignment is Flogel Limited has just produced the first full batch of a new product, taking 200 hours. Flogel has a learning curve effect of 85%. How long will it take to produce the next 15 batches? Flogel expects that after the 13th batch has been produced, the learning effect will cease. From the 31st batch onward, each batch will take the same time as the 13th batch. What time per batch should be budgeted? So you can try and see what you can do in relation to this question. So in learning curve, there are instances where you will not be given the learning rate, and you'll be expected to determine what the learning rate. I think we'll talk about that when next we meet. In brief, it's not anything complex. It's just using a formula too, and the formula is AR to the power of n equal to cumulative average time per unit. So we'll talk about that when next we meet, where you are not given 85%, you are not given the learning rate, and there is no any link for you to get the learning rate. How do you determine the learning rate? Yes, you use a formula to determine that. So we're going to discuss that in brief when next we meet. Then I've been looking for questions in the Pathfinder. I always attach to some other things, to some other topics. When it comes to learning curve, you won't see a full-fledged question on its own, but I'll still bring up a question from the Pathfinder. But once you can tackle this, you'll be fine. But there is one very good question I have here. Let me see. It's an ACCA question. I treated last diet with a private class like this. We will look at that too. This is a question I've adapted from the Kaplan performance management. It's a very good question with much more issues. So I will forward the question also. You read and see what you can come up with. When we meet, we'll also solve this. Yes, so it's a question that is very good to broaden our horizon likewise on the concept of learning curve. So that is that for tonight. I just want to have the class for 1 hour. I need to go.